Welcome everyone to this final part of our four-part webinar series where we've been looking at structural steel within the AEC collection using Revit and Advanced Steel. My name is Rob Merriman. I'm one of the application engineers within the structures team here at Graitec. Just a little bit about my background if you didn't catch me on the first webinar. My background is in steel and metalwork detailing. I've had 7 years industry experience working as a draftsman for 2 subcontract drawing offices, both using advanced steel. So if you do have any questions, as me and John have both said in this webinar series, please reach out. You've got all our contact information, so please reach out to us. Like John has done in the last few webinars, I've created a handout. So in the handout dialog, there's a PDF for you to download. It's a copy of today's slides, and it's got hyperlinks to my email, my Twitter, the previous recordings, and some a bit of additional information that got sent out yesterday by Autodesk. Regards to questions, if you type the questions, what I'll try and do is just leave all the questions to the end, and then we'll either answer them at the end depending on time, or what we'll do is we get a copy of all the questions asked sent to us, and then we can reply individually to those. So before we get started with today's webinar, we're going to have a look back at what we've already covered in the previous 3. So the first one, I started by looking at the new steel tab within Revit 2019 and how we can achieve a higher level of detail in our Revit model. Parts 2 and 3, John Bennett took us through the Revit to Advanced Steel collaboration and the mechanisms and the tips and tricks for getting the model through. And then today we're going to look at how we can get fabrication drawings, schedules and lists and all of the output automatically using Advanced Steel, and what tools we can use within Advanced Steel to make sure that we don't have any errors in the model. I think I said it in my first webinar, it's just one important thing to take from this series is we're not just promoting one workflow that's going to apply to everyone. Lots of you who have joined today are experienced Advanced Steel users, and then some of you are experienced Revit users. We're not saying that you need to forget everything from one program and learn everything in a new program, but we just wanted to highlight the work that Autodesk have done in 2019 to get the workflow between Advanced Steel and Revit working a lot better. And like I said, you've got our contact information, so please reach out to us if you want to see any more or discuss certain things specific to your business. So what we're going to look at today is we're going to look at, well, I've completed my Revit model with all my connections, so I'm going to export it and then import it straight into Advanced Steel. Then we're going to look at the tools in Advanced Steel that we have for checking the model, different things that we can do within there. Then I'm going to move on to model roles and their importance, and we will talk a bit more about that. These drive the numbering and the drawing output. And then we're going to create our fabrication drawings. We're going to run our schedules, and I'll show you 5 different schedules that I always used to run for clients. And then we're going to look at the NC and the DXF output. So I'll just crack on. I just want to check with you guys. Again, if you could put it in the chat window, can you see my Revit model? Because sometimes with presentations, the Revit models just don't, the presentation doesn't just quite show properly. Okay, lovely. So here's my Revit model. I've got all my connections finished, all my custom connections. My model is complete to the level that I want it. So I'm just going to use the Advanced Steel extension and export the model. And I'm going to be working on my desktop today. And I've called this our Shipley office as an example. So I'm just going to save the SMLX into there. So that is exported now. So then I have my Advanced Steel 2019 up and running. So what I'm going to do is I'm going to start a new template file. I have my own custom template that's got some bits and pieces in there, which we'll get to as we go through this webinar today. And then I'm going to go to the Export and Import tab. And then we'll go and import my SMLX file. So we'll just let that tick away. There has been recently a Revit 2019.1 update, and it now seems to show you the import as it's going along, whereas before it just seemed to wait it 3 or 4 minutes or so and then give you the export. So we'll just wait for this to come back to me. Just going to wait for the grid lines to come in and it's just to finish the import. Okay, so you can hopefully see that I've set my template up so that the colors and everything look the same, but if I compare the two, everything has come through as I would expect it to. So the first thing I'm going to do, I'm going to save this file. Very important that we save our advanced steel file, and we will give it an appropriate name. So that I know it's the advanced steel file. Just some information that I'm going to put in, same as a Revit file, I'm going to put the project information in. If I could type properly. I'm putting this information in because it will come through like Revit onto the sheet information a little bit later on. Got to master the use of the caps lock button. So there's my project information. So we're going to crack straight on with the checking that we can do within Advanced Steel, because a lot of the stuff we've done in Revit, I've done some manual connections in there, I've manually welded bits and pieces in there. So Advanced Steel is now, I'm going to use the tools within Advanced Steel just to make sure that everything that I think is welded together is welded together. I don't have any clashes and things like that. The more time I spend in checking now, the less errors I will get on my fabrication drawings. So these are all tools that are just standard in Advanced Steel. So the first thing I'm going to look at, I brought my model in, I'm just going to clash check the model. So on my home tab, under checking, I have a clash check button. Similar to how you'd export it to Navisworks, so for you guys that use Revit. And what I get a dialog box with every clash within the model. So I've got 38 clashes now, because I do this day in, day out, and for those of you that use Advanced Steel a lot, what it is saying, if I double click on a clash, it will zoom to it. If I change myself to a wireframe, we'll actually be able to see it. At the moment, these anchors are clashing with my foundations. So I could go through and there's an option just to ignore clashes, or I could change the behavior of my foundation to say, well, don't use for clash checks. All of these ones, you can see that it's anchors clashing with a foundation. I'm not worried about those. The ones I'm interested in here are I've got an RSA clashing with a column. So if I double click on it, because I'm in a wireframe, I can see that I've put different connections in this model just so that I was trying out all the different, or most of the connections within Revit. So I use clip angles. The angle at the moment is actually clashing with the root radius of the column we can see in there. Although the display type doesn't show the radius, Advanced Steel same with Revit, is programmed with all the radiuses. So it knows if I change that, you can see the radius is in there, but to save graphics, we have it turned off as a default. But the system, when it clash checks, will always clash check against every radius. So that joint, I've got an issue with. So because it's been modeled as a joint in Revit, Advanced Steel still recognizes it as a joint. So I can simply, I'll close my clash check dialog box down. I can go into here. It's exactly the same dialog as the Revit one, slightly different formatting, but I can change the angle size, and then I can do, I can clash check just a selection, so I can just clash check around that, and then this time it's found no errors. And I know that that joint is applied to this position as well, so we can just change that one. So that first one is my clash check, and that will highlight any obvious errors where you haven't put a clash in, where you're clashing with radiuses, where you've set the joint up incorrectly, you've used a wrong figure. it will clash check every object in the model against all the other objects, concrete, steel, bolts. It will also tell you, for the guys who are erecting the steelwork, Advanced Steel and Revit both know that this is an M20 by 50 long bolt, so the bolt length is 50. The clash check physically checks that there is enough room in here to get the bolt in. So it will tell you if the head of the bolt was going to clash with the bottom flange of this haunch. So the clash check is a very powerful tool within Advanced Steel. The next one I'm going to move on to very quickly is steel construction technical checking. It's a bit of a mouthful. It does come up with a long list of issues, and it's saying that some bolts are too close to the object's edge. That is checking against certain edge distances within my system. It's obviously the connections will be provided by a connection engineer who has the edge distances set up in his system and the edge distances he wants to work to. So I'm actually going to ignore 99% of what shows in here. But what I am interested in is this line here. Some holes in the hole pattern are outside of the connected object. So it's on this beam. So if I isolate this beam and turn its features on, I've actually modeled it in Revit. And I've actually put the holes accidentally outside of the object. So the steel construction technical check will highlight that for you, because if we sent this to an NC machine, we wouldn't, the NC, it would try and plow a hole in the middle of nowhere. It would actually give you an error on the NC file and tell you it, but we don't want to get to that stage where the NC file is telling us. We're going to use the tools within Advanced Steel and correct the model before we get there. And the other option we've got is it will tell you if welds only connect to one object or if they connect to no objects. So a weld by definition is to connect two elements together. When you put the welds in Revit, you could accidentally only select one of them and miss the other item that you're connecting to. So it's telling me for my manual haunch joint, that's not my manual haunch joint, sorry, my manual column joint, that this weld in here is only connecting to one element. So when I put it in Revit, I must have missed that I hadn't selected both this item and this beam. So in Advanced Steel, I can actually add an object to a connection. So I can pick up the weld, just clear the marking and then pick up the weld. And then I can say attach that to those two items, and now that weld has now attached both of those items together. So that's the steel construction technical check. The next check I'm going to do is I'm going to run a check for, change myself back to realistic so we can see. We have a check for loose parts. Now in the model, so if I run this check, it's found 31 loose parts. So I can select those and isolate them. And we'll just clear the marking to see what we've got. Now all the foundation information, well, they are loose, so that's fine. I can select those and say, well, I'm not interested in those. These three beams in here are on fin plates at both ends with nothing else connected, so I would expect those to be loose, so I can say, okay, I've checked those. I've got some loose angle cleats in here. Those are to be expected as well because they are angle cleats bolted on both beams. And then I can see what I'm left with. Well, I do have two items in here, and they are from my cap plate. So for those of you that were with us on the first webinar, when I put the cap plate connection in, I must have actually forgotten to put a manual weld in to weld the cap plate to the column, because that was done manually. So all of these checks that I'm running are to try and highlight to me errors that have been done manually. The joints that are put on automatically by Revit and Advanced Steel, they won't have any errors. It doesn't miss welds, but when you do it manually, it's a user input, so there's always the risk that the welds can be forgotten. So I will just select both of those, put a fillet weld in, just like we did in Revit in the first morning, and we'll put a weld in there. So I've checked my loose parts, I've done my clash check, I've done my steel construction technical check. The last bit I want to check, I I used to do this on every beam in every model. Some people say it's overkill, but I always found it just saved me a lot of hassle if I'd got my assemblies wrong. When you're manually welding things together, in Advanced Steel, we have tools to check what's attached in the workshop. So I can click this button and I can click on the rafter and it highlights everything that is attached in the workshop. So I can make sure. Now, like I said, because I've used a haunch joint and an apex joint, it won't mess the welds up. What I'm interested in here is the stuff that you do manually. So the items that I created manually are this assembly here. And we can actually see that in this first one, I've forgotten to weld this haunch piece and this end plate, sorry, the haunch piece to the column. The end plate, if I clear the marking, is attached to the stub section, which I expect it to be because it's done with a joint. But that stub section, it was my responsibility to manually weld it to the column. So if I hadn't have run this check, what would have happened is I would have got an assembly drawing for the column and a separate assembly drawing, which if the workshop hadn't have picked up on it, would have been finished and sent to site, and then they'd have to site weld it. So these are the kind of things that I'm looking for in my Advanced Steel model. Anything that I do manually, that if I've missed, I can just correct before I run all the fabrication output. It especially comes in with things like I have this as a whole welded frame that we did on the first webinar. So I can see that that is all red. So that is all one welded unit. So personally, as a draftsman, when I was working as a draftsman, I went through every assembly and turned them off once I checked them, just to make sure that what was welded properly. The next thing I need to check for is model rolls. Now what I'm going to do is I'm going to just run my check and then I will go back to the slideshow and explain what model rolls do and how they work. But basically, I'll sort of talk as I'm doing this. Every item within this model needs a name. Anything, so if I go to these are rafters. So in here I have a model roll and I have a model roll called rafter. Now there are a couple of anomalies that I need to send to Autodesk and discuss with them, because if you use a joint, it should automatically assign the model roll, and it does for pretty much everything, but we just noticed that a couple of connections it hasn't actually put the model rolls on. So I will be emailing Autodesk to get them to get the developers to investigate it. But I just need to make sure that everything in my model has a model roll. And I will explain what the model roll does once I start running the fabrication drawings, because it will take me a few minutes to get the fabrication drawings run, so I'll go back to the slideshow while it's doing it. And I have a little, what we call a query, so I can just run that query automatically and it highlights anything that doesn't have a model roll for me. So I don't need to click on each one individually. I can just run the search query, and as I assign the model rolls, I can turn that query on and off, and I'm just left with the items that don't have a model roll. I will show you why this is important, that this is done for every item. So these end plates, these little end plates in here, and the model rolls are, there are a lot of them, but if it's a rafter, you call it rafter. If it's a beam, you call it beam. So these are end plates, so I will call them end plate. These plates down here are a base plate, so I will call them base plate. And these are stiffeners, so there is a model roll for stiffener. So if I just rerun that search again, I'm left with a blank model so that I know everything has a model roll. So I've run all my checks, so I'm now ready to, I'll just save that, I'm ready to run the numbering on the model. an Advanced Steel, the numbering on the model, I click the numbering dialog. I have it preset up within my template as to how I want it to number. But what the Advanced Steel numbering will do, it compares every object in the model and will tell me that I've got 8 of these beams, so that when I click on them, there are 8 identical assemblies. So that's my model numbered, and you'll notice that as I'm doing each one of these items, I'm pushing save on the model. So what I'm going to do, I'm going to get my Fab Drawings running, and it'll take me a few minutes for it to run everything. So I'm just going to run my part drawings, and I'll go back to my presentation and we'll look at the model roll and what it does. So when we assign a model roll, what it does 2 things. It assigns a numbering prefix. So for example, everything that I call beam, it will call B1, B2, B3, so on. If I use the model roll column, it then gives a prefix of C1, C2 for the columns. Rafters, R1, R2, stringers, SG1, SG2, so on and so forth. You can completely customize them if your company wants to do something different. The other, and this is hugely important thing that the model roll does, is it assigns a drawing, it triggers a drawing style when I run drawings. So for example, if you as detailers want to detail a beam, you will put certain information on that drawing, like overall length, where the attached plates go, what weld information is there, the mark numbers, where the holes are set out from the top of the beam. All of that information will be completely different to a rafter drawing and a stringer drawing. So Advanced Steel has these drawing styles set up in the system, and the way I sort of explain it is, imagine it's a filing cabinet, and when you want to get a beam drawing, it goes and picks out the file for the beam drawing and uses the information within that file. When it does a column, it goes to the column drawing. When it goes to a rafter, it picks out the rafter file. But you need to set the model roll in order to trigger that drawing style. So for the beams, we have a beam style, columns, we have column styles, rafter, we have rafter styles, and so on and so forth. We'll just see, that is still just ticking away. We'll hope that comes back in a second because I've still got assemblies to run. I might just run a selection of assemblies. When it runs the numbering, so I'll explain while this is ticking away what it does for the numbering. It compares everything in the model against everything else. So it will compare the beam section sizes. If the beam section sizes are the same, it then compares the material grades. If the material grades are the same, it then compares the length. If the lengths are the same, it then compares the hole information. If the hole information is the same in terms of hole sizes, hole position, hole quantities, it then looks at all the end plates and the attached parts, and if all of that are the same, it will put all the numbers, it will give it the same number. If anything is different, it will give it a separate number. I know in Revit, if you were doing, you can do assemblies in Revit, and then you obviously have to name it. You obviously have to go through that, and then it's up to you to manually do it. So by putting the model into Advanced Steel, this is where the system will do it for you. So I'll just run a few assembly drawings because I don't want to waste everyone's or go over the allotted time. So I'll just do it for a selection. What this is doing, it works slightly differently to Revit. Everything that I'm creating here, it creates as a separate intelligent drawing file. So if I go to look into my folder, when I saved my model, I called it Shipley Office and it's a DWG. This folder did not exist. As soon as I push the Create Drawings button, it creates the folder and it creates the subfolders. And these are all my part drawings. You have the DWG and you have an update file, so that if anything in the model changes, the drawing will tell me that it needs to update because it doesn't match the model anymore. So it's slightly different to Revit, where Revit, everything is contained within the one project. Advanced Steel, it creates the subfolders and all separate files for you. So I'll just let this finish. When we're training Advanced Steel, when we're talking to people about model rolls, model roll is almost the most important thing I would say, alongside clash checking to make sure that you get good drawing output. So I will show you some examples of a bad drawing output because the wrong model roles have been used. So this on the screen now is someone tried to model this as, or we modeled it in the office. It's a roof bracing, but the description in here, the model role, we called it a beam. And we called these just plates, not the correct model role. So that is what it ran automatically, which as a detailer is not very good. When we changed the model role to roof bracing, it triggered a different drawing, which gave different labeling and dimensioning strategies. So the only thing that we've changed from that to that is what is the model roles in the model. This is a rafter drawing with the model role beam, and these have just been called plate and beam, so they've not used the correct model roles. We corrected the model and ran it automatically, and that's the difference. So you can see the difference in drawing quality between the two items, and the only thing that's changed is the model role. And like I said, if we look in this model, I'll shut that down. Anything that is a joint, the model role has been automatically done. So all of this information in here, so you don't need to do the model role for every single piece. You just need to do it for the bits that have been modeled manually. So all my fab drawings have now been run. I'm going to run the NC files for the model to send it to the drill and saw line. So I just click the NC button and it will take about 2 seconds. That's all the NC files created. And I want my plates to be profiled. So we have a DXF just for plates button. So I click that and that will create a one-to-one cutting profile with a mark number on for the plates. And the last bit I'm going to show you guys is the lists or the schedules that we can get from the system. So we have, in Advanced Steel, we have these tool palettes that pop up when we require them. So I'm going to start with a material list. So I click the material list button. It will run the list for the entire model. Again, I can create it as a separate file. So we'll just let that, it collates all the information from the model. We'll just wait for it to pop up. It's gone onto my other screen. And what it does is it groups the items by section size, gives me the overall length, and then gives me the individual lengths of the items. It will also tell me if it's an exact square cut or if it has a bevel on it. And you'll see that the client information and the contract and the job number have all come from the project information I put in at the beginning. I can then export these to PDF, Excel, and a Word document. That has just popped up on a different screen. I just need to bring it there. And you'll notice that it's automatically now created me a separate bill of materials folder within the same job folder. So the first one I ran is a material list. So once the material has been ordered, it gets delivered to the workshop. What we found with a lot of people is they get 2 or 3 lorry loads of steelwork delivered to the office and they don't know which parts are for which item. So I always used to run an assembly list, which would tell the workshop manager when he's making a particular assembly. So if we look at rafter 5, R5, there's one of them. You need to go and get all of these pieces. And these are the mark numbers, these are the section of the material. It gives you the overall weight. So the workshop manager can go out to the yard and just collect the pieces that he needs. And then as they're fabricated, he can tick them off on his list to say that he's fabricated them. The next list I'll run is a loading list. We called it a delivery list. And this will help the people loading the steel onto the lorry for delivery to site. We've also found it saved a lot of issues with arguments with site people. So what it does is it gives you the assembly number, the quantity, the main section size. It then gives you just little boxes to tick when they've been loaded onto the lorry and that they've been received by site. Because what we used to find is that, especially on a massive site, steel will get delivered to one corner of it and it might get moved around and they might lose a beam. And then they would argue that you as the fabricator or the supplier never sent that beam, whereas now you can get them to sign a delivery list so that they have received it. It will then also, we found it useful for ordering cranes in, because it gives you the weight per assembly. So you can quickly scan through the list and see the heaviest item of all of the steel beams and order the appropriate crane. The last two I'm going to run is a bolt and anchor list, so it's a bolt schedule. All of these lists can be fully customized to have your logos in, your text heights, formatting, but what it does, it gives me a breakdown of every bolt required on the job and every anchor. And what I can do with these quantities, I can actually add a percentage value in there, so it will add an extra 5% if required. The issue with this is I've got M20 by 55s, by 50s, by 45s. Generally, they get delivered to the guys erecting it, and they get 3 bags of bolts, and they don't know what bolt goes where. So Advanced Steel knows what bolt is associated with what beam. And we can run a list based on that information. So I can, in here, if we scroll down, we'll look at B5. B5's got a few bolts on it. So when you're installing B5, you need an M6, you need 2 M16 by 40s and 6 M20 by 45s. So the site guys know which bolts to use on which beam, and they won't end up using all of the short bolts where they needed to use the long bolts and vice versa, and then end up not having the right bolts at the end of the job. So that really quickly are the checking tools that we can use in Advanced Steel, how we number the model, how we get the drawings out of it. The drawings are controlled by a document manager, and every time you open this, it checks every item against the model to make sure that the item is up to date with the model. And this is the kind of information that gets run automatically on the plate information. So these are my fittings. So it gives me all the hole information, the cutting information. We'll go on to shafts. So it gives me the overall length, the angles, the cut values that are in there. So this was all run while I was showing you those few slides. And then we get the assembly information. And it does run me a bill of materials within each drawing. So it tells you the single part numbers that you need to make the assembly. And then if you remember back to the first webinar I did where I set the 10mm fillet welds all round on the columns, that information automatically comes through with welding symbols into the fabrication drawings. My NC files are all controlled through the document manager as well, so we can see the DXFs that were created. So these are one-to-one cutting profiles on correct layers that you can then load straight into a profiling machine. And the NC files are data files for a drill and saw line. So if we look at some of the shaft information, this gives the job number, the mark, the correct material grade, the section size, and then this information in here is the length, so it's 4 meters long, and then it's got a 45-degree cut and a minus 45-degree cut at each end. So you can send this information to your supplier, they can pump it straight into the drill and saw line and delivered all the beams drilled and cut. So we'll go back to slideshow. So that really quickly is the end of today's webinar. Additional information, like I said, this is the last in a 4-part series. So in the handout that I've put in there, I've put recording links to all 3 of the previous webinars, and we will send out a link to this one when it's been uploaded. And yesterday, Autodesk actually started a new YouTube playlist, basically covering the topics that we've gone through in the 4 weeks of our webinar series. So they now have a detailed steel design with Revit 2019 and steel fabrication with Advanced Steel 2019. They currently have 10 to 15 short 2 or 3 minute videos which goes into different areas of this workflow and of these 2 tools that we've been looking at. So like I said, that is the end of today's presentation. If you do have any questions at all, please drop me an email, please contact me on LinkedIn, Twitter. If you want to discuss your company's workflows, please contact myself and John. I'll leave the presentation running for a couple of minutes, so if you want to get any questions in, please do. And like I said, if they're short and I can answer them now, I will do. If not, I will get an email copy of all questions, and then we can get back in contact with you. But that is the end of today's presentation. So thank you very much for attending our series of webinars, and please get in contact if you do have any questions.